In this video, we'll be looking at 6.4, solving systems by elimination using multiplication. So our essential question will be, how do I solve systems by using elimination when coefficients are different? How do I solve systems by using elimination when coefficients, there's an I right there, are different? Okay, so let's go through our steps. It's very similar to when the coefficients are the same. We just got to do some manipulation using multiplication to make those coefficients similar but opposite. So first thing we'll do is write equations vertically. Our second step will be, and this is the new step, multiply 1 or both by a number so that one variable has the same coefficient but opposite. So this is the big new step. Sometimes we'll be able to get away with just multiplying one of the equations by by a value, by a number, so that we'll have the same but opposite coefficients, and other times we'll have to multiply both equations. So let's look at, so then our step 3 is to add the equations. Eliminating a variable. Step 4 will be to solve for the remaining variable. So once we eliminate a variable, that process kind of starts repeating itself. Solve for the remaining variable, plug back in, and solve for the other variable. So we'll add the equations eliminating a variable, we'll solve for the remaining variable, and then plug back in and solve for other variable. So let's go ahead and see if we can do this. Let's look at example number 1. Step 1, write the equations vertically. So I have 5x plus y equals negative 10. And I have 2x minus 3y equals 13. So I'm looking at these equations. What's the easiest route to get my equations to have matching but opposite coefficients. Well, if I multiply this top equation by a 3, I'd have 15x and a 3y, then the y's are matching with opposite, 3y and negative 3y. So I'm going to choose to multiply my top equation by 3. So we'll distribute that 3 to everyone, and let's see what we get. So I'll have 15x plus 3y equals negative 30. And this one I'm not manipulating. I'm doing nothing to that second equation because we'll have those matching but opposite coefficients, and that's what I'm after. And now we're at that place where we can add vertically, and we'll see that one of the variables eliminates. So I'll add my coefficients together, and I get 17x my 3y and my negative 3y cancel, and equals negative 30 plus positive 13 is negative 17. And now we have just to solve for x. Divide both sides by 17, and we get x equals negative 1. Same process to finish this up. We're not done when we find one of the variables. We got to find both. So we'll plug that back in. Let's just choose the first one. So we'll go 5 times negative 1 plus y equals negative 10. So we'll have negative 5 plus y equals negative 10. Add 5 to both sides, and we have y equals negative 5. And now we're essentially finished with the problem. We just have to put our answer together. Write it as x comma y, so I have negative 1 comma negative 5 in parentheses, illustrating that it's a point, x comma y. So we multiplied one of the equations so that we could have our matching but opposite coefficients, adding vertically, solving for one variable, plugging back in, solving for the other variable, and then writing our solution as a point. So this is where we have to multiply one equation by a constant or a number. Let's find an example where we have to multiply both equations by a constant. So go ahead and flip the page. And let's look at number 3. So if I'm doing it this way, actually I'd rather look at number 6. I think number 6 will have a little bit more to it, so that we have a really solid example for this. So we'll do our first step, stack the equations. So I have 2x plus 3y equals 10. And then I'll have my 4x plus 6y. Nope, this one doesn't need that, so we'll scratch that. Sorry about that. We'll do number 3. So let's do that. We'll stack our equations. 3x plus 2y equals 5. And then 2x minus 5y equals negative 41. Now there's no one magic bullet, I guess you could say, where I could turn the 3 into a 2 or the 2 into a 5. So instead what I'll do is I'll multiply both equations by a value. That way I can get our matching coefficients, but opposite, and then we'll be able to combine them. So for me, what I'm going to do is I'll turn, I'm trying to find a common multiple of 3 and 2, so that'll be 6, but I need them to be opposite. So what I can do is I can multiply this equation by a positive 2. And I'll multiply my bottom equation by a negative 3. This way, when I do my distribution, I'll have a positive 6 on the x on my first equation, and on my second equation, I'll have a negative 6 attached to my x. So let's go ahead and do that. So my top equation is now 6x plus 4y equals 10. And my bottom equation is now negative 6x plus 15y equals positive 123. Negative 6x, negative 3 times negative 5 would be a positive 15y equals negative 3 times negative 41, positive 123. Now when we combine these, we can see our x's disappear, and we're ready to just kind of go through the motions. My x's eliminate one another, and I have 4y plus 15y is 19y equals 133. We'll divide both sides by 19, and we get y equals 7. So remember, that idea is always that I need to get same absolute values, 6 and 6, but opposite each other. So a 6 and a negative 6. That way when I add these equations together, they will eliminate. Those x's will disappear. So sometimes we'll have to multiply by a negative value to make that happen. And sometimes we'll have to multiply both equations by a number, different numbers, just so we can get that same but opposite. Okay, so let's go ahead and finish this problem up. We'll plug back into one of our equations. I'm going to choose the first equation. So we'll have 3x plus 2 times 7, plugging my y back in, equals 5. Going through our motions, 3x plus 14 equals 5. Subtracting 14 from both sides. Now 3x will equal negative 9. Divide by 3, and x equals negative 3. We have our x value, we have our y value, always looking for those two values to find our total solution, and we'll write it as a point, so negative 3, comma, 7, and we've solved the problem. So there it gives us two solid examples, one where we have to multiply both equations, so let's label them. So there's our multiply both equations by a number example. And then one on the page before is multiply one equation by a number. So let's turn back and label that one as well. So we have solid examples of each. So thank you for watching this video, and I hope you have a great rest of your day.